CSO estimates that the average annual income of all the wage earners in India is 75,000 with a standard deviation of 6,000 rupees. A private research organization was asked to test the official estimate at 5% level of significance. A random sample of 3,600 wage earners was taken across the country and found the sample mean as rupees 73,250. We need to analyze this question first. Here, they were first talking about the population and then they went for the sample. Again, to understand what these are, a population is just a complete, it's like a country. It has, let's say India. India has 1.23 billion something. If we take a specific state from this country, let's say Telangana, that would be a sample. I mean, the sample is still part of India. This Telangana is still part of India. A sample is a part of the population. This is the entire population. It contains some elements. It contains some n number of elements. If we take some elements from this population, this specific population, this would become the sample of that population. It's literally what sampling means. Now that we have an idea of what population and sample are, let's try to understand this specific question. CSO estimates that the average annual income of all the wage earners in India is 75,000 with a standard deviation of 6,000. Here, they have already specified that this is a population by saying all the wage earners in India. They didn't specify it as a sample, they just directly assumed it as a general population of India, and they have an average, meaning they have a mean value of 75,000. Since this here we are talking about the population mean, here CS estimates that the annual income of all wage earners in India is 75,000. This is population mean. This average is equals to mean. So this will be mu is equals to 75,000. We have that. Now, we also have the standard deviation. Usually, mean may not be denoted directly by mean, and they will just call it average or mean. So if there is a word called average or mean inside the question, it's probably mean. Since this is population mean, we denote it using mu and with a standard deviation of 6,000. Standard deviation will directly be denoted by saying standard deviation. There won't be any twist to it, so there is nothing to be confused about. And again, this standard deviation is part of this entire population. So this standard deviation belongs to the population rather than just the sample. So to understand, then actually what is the standard deviation of population? Usually the population parameter for standard deviation is sigma, and here sigma is equals to 6,000. A private research organization was asked to test the official estimate at 5% level of significance. Okay, they have specified at what level of significance we have to test this sample at. So now that we know what level of significance, this will usually be at either 1% or 5%, either of the two. If they do not specify it, it's usually gonna be 5%, and it's always gonna be two-tailed. That's it. These are the things to remember. Okay. Now that we know what level of significance we are using, we need to understand the concept of the question. A random sample of 3,600 wage earners was taken across the country and found the sample mean as 73,250. Here, the sample size, I mean, from this population, they are taking a small sample, and that small sample is 3,600. Let's say from like 1.32 billion population, They just took a small sample of 3600. We are testing the sample, not population. We are testing the sample. So the n will be denoted as 3600 because that's how many wage earners we are actually basing this test on. So the n is 3600. Was taken across the country and found the sample mean as 73,250. Now from this sample they directly denoted it as sample mean. If they denote it as an average, it's still going to be sample mean because this average is part of the random sample and not of the population. So this 73,250 will be denoted by x bar because this is sample mean, this is sample mean, this is population mean, and this is population standard deviation. And while this n is just a sample size, x bar is a sample mean. Okay, what is the sample mean then? 73,250. Okay, we have these four values. It's up to us to identify which method we are supposed to use for this, and we can only understand what method to use only if we know all the formulas of all the testing methods we use. This one is a single mean, so for single mean the test statistic will be x bar minus mu by sigma by root n. Do we have the x bar value? We do. Do we have mu value? We do. Do we have the sigma value, the sample, the population standard deviation? We do. And again we have n. If we just plug these values in, let's say x bar, what is x bar? 73,250 minus 75,000. X bar is 73,250, mu is 75,000. Now 6,000, which is standard deviation. In place of sigma we placed 6,000 and root over 3600 because n is equals to 3600, and according to the formula we are using root over 3600. If we calculate this let's calculate the denominator first. 250 minus 75,000 by 6,000. This will be 60 and this should cut. This will be 100. 73,250 minus 75,000 by 60, 100. This will be 100. This is approximately 17.5. This will be negative, but it can be converted to positive because we usually take mod z equals to minus 17.5. Now that we know what value we are getting for this specific sample, if we use this one mean test, we need to actually compare this to understand if the value we are getting is accurate or should it be rejected. For this we will use these tables called the Z tables or the T tables. Here we can see that according to the sample size we are going to take the 5% or 1%. For our question they specified specifically it's 5% level of significance, and if they don't specify two-tailed test or one-tailed test, it's always going to be two-tailed test, and if they don't specify the level of significance, it's always going to be 5%. It's always going to be 5%. Now what is n for us? N is 3600, and in this specific table we don't have a specific value for n, so we can just consider it as infinity. And here for 5% level of significance we have 1.960. This we have to compare to the mod z value. So this is to draw a conclusion from our test. So the conclusion would be Z alpha, which is alpha is nothing. It's literally what level of significance we are taking. That's it. That's literally what it is. Okay, let's just consider it 5 Z at 5%. Z at 5%. Okay. Now this is Z at 5%. What would it be? It's 3600. 5% two-tailed test. It is 1.960. It's one. This is not 75. This is Z at 5% level, 1.96. Our mod Z value, how much did we get? We got the mod value would be plus 17.5, which is 17.5. So 17.5 is indeed bigger than what we are taking from the table. Again, the compared value from here we have calculated 17.5, but the table value is only 1.96. We can only accept H naught. This, let me just say, mod Z greater than Z alpha. So we only accept H naught if mod Z is less than Z alpha. So mod Z is actually greater than Z alpha here, but we only accept H naught if mod Z is less than Z alpha. For our specific question here, we got 17.5, which is way bigger than 1.96. So we have to reject H naught. This H naught is also known as null hypothesis. So what we have to do is find all the values, understand what is the population mean, what is the sample mean, what is the standard deviation. Actually, just finding out what values they have been given inside the question will let us understand what method to use. For that, we need to learn every single formula so that we know what method to use. In the exam, they won't specify which method we are specifically supposed to use, so it is just our own knowledge to understand it. So Z is equals to, now that we use this one mean formula, we plugged in the values, we used the formula, got the value as 17.5. To draw the conclusion, we have compared that 17.5, we compared the 17.5 to a value in the Z tables, to a value inside the tables. If the value we calculated is less than the value inside the table, then we can accept H naught. Else we have to reject H naught.